All right, here we go. A few more. All right, we have this function y equal to 5 divided by the cube root of x squared plus x plus 1. All right, so as it's written, it's a quotient. So we might be thinking quotient rule, but there's no variable term on the top. So we can actually do this without quotient rule. All right, so how is this going to look? And the idea is we kind of go through our usual strategy. So we see a root sign here. Let's rewrite that root function with just a regular power, a regular exponent. So first of all, I would write this as 5 over, and then instead of the cube root, we could write this as x squared plus x plus 1 raised to the 1/3 power. That's getting rid of the cube root, getting into a form that we can differentiate. Now we can also write this. We have a fraction where all of the x terms are in the denominator, so we could rewrite this with a negative exponent. Another one of our usual things that we do. If we see x terms in the denominator, rewrite it with a negative exponent. So we could write this as 5 times x squared plus x plus 1 raised to the negative 1/3 power. So the negative comes from the fact that it was in the denominator. The 1/3 comes from the cube root. All right, so now this is a nice format, and we can actually differentiate this now using chain rule, specifically using our general power rule. So why are we going to use general power rule? Well, we see that kind of one of the last things here is this power function. So we have an inner function, x squared plus x plus 1, and it's actually inside this power function of raised to the negative 1/3. So what is, if we're looking at this, what's the outer function? It's raised to the negative 1/3. And what's the inner function? X squared plus x plus 1. And actually, if we wanted to be super precise, we could think of our outer function as being 5 times that power function. All right. So what would the derivative look like? We want to calculate y prime. So it works just like we kind of go through how we go through regular power rule. So we take this exponent, this negative 1/3, bring it down, put it in front. We'll multiply it with the 5 that's already there. So we're going to get negative 5 over 3. We keep everything inside the parentheses exactly the same. So we go from, and then we subtract 1 from the exponent. So we go from negative 1/3 down to negative 4/3. It's not the end of the story. Then we take those inside terms, the x squared plus x plus 1, and we multiply by their derivative. So we take the inner function and we multiply by its derivative. Notice that our inner function over here stayed exactly the same. We didn't do anything to it. All right, and we just keep going. So this one is much easier to do, and we finish. So our negative 5/3, we're done with that. We have our x squared plus x plus 1 raised to the negative 4/3. That's all good. We're done with that. And then finally, we multiply by 2x plus 1. And there we go. So we've calculated this using the general power rule. All right. Good practice. Let's try another one. F of x equal to 5 times the natural log of square root x. And again, we have a root function here. So let's rewrite this without the root sign. So it's 5 times the natural log, and then square root x we can write as x raised to the 1/2. And using parentheses, we really emphasize, what our inner function is and what our outer function is. So when we look at this, the outer function is the natural log part. Well, maybe the 5 times natural log part. And then the x to the 1/2, that's actually inside the log function. So our outer function is 5 times natural log. And our inner function is what's inside there, x raised to the 1/2 power. All right, so how are we going to differentiate this thing? Well, we know our outer function. It's a log. So we're going to use that general log rule, really just a special case of the chain rule. So how does it work? Well, 5 is a constant multiple, so that just kind of sticks around. Nothing's going to happen there. We want to differentiate the log part, so it says take whatever you had inside, do the reciprocal, so make a fraction. So we're going to do 1 over x to the 1/2. Don't do anything, so this x to the 1/2 stays the same for this part. So we're just differentiating the outer function right now. Derivative of the natural log part says do the reciprocal of whatever you had inside. Then we take that inner function, x to the 1/2, and we multiply by its derivative. So again, we're kind of breaking this up into 2 steps. First step, differentiate the outer function, and then the second step will be multiply by the derivative of the inner function. All right, so now derivative of x to the 1/2, not too bad, just power rule. So we get 1/2 times x to the negative 1/2. And we could actually simplify this down quite a bit. So let's do a little bit. I would take the 1/2 here and the 5 here and just multiply those together. So put the constant terms in front, so 5/2. And then this x to the negative 1/2, I could rewrite that as a fraction. So x to the negative 1/2 I could write as 1 over x to the 1/2. And so then I have 1 over x to the 1/2. And when I multiply those together, I would end up with just a 1 over x. So this is another way to, well, let's actually show that. So I would end up with a 1 over x to the 1/2 times a 1 over x to the 1/2. And then if I have 2 square roots of x and I multiply them together, square root x times square root x is just x. So there I go. Have a nice derivative right there. Now, there is another way. There's a much easier way to do this using properties of the log function. So we'll be looking at those in a little bit. But there's a property of the log function that lets us do something with this exponent. So kind of a little teaser for what's going to come up in a few lessons. We're going to be looking at properties of log functions. So there's maybe a slightly easier way to do this particular one, but this is perfectly good. Just using the general log rule here. All right, so a couple more examples in the next video. Just working on these, developing, practicing. Really the main skill here comes from being able to identify what's the outer function, what's the inner function. And so it just comes with practice. So we'll see those, and we'll see those next.